Yeah, welcome you once again to Kenya Kum Mathematics Classroom. This is our question for the day. Using the matrix approach, solve the equation x plus 2y equals 4 and minus x plus y equals 5, okay? So this is a simultaneous equation. We have x plus 2y equals 4, then we have minus x plus y equals 5, okay? So this is what we are given to solve. This is what we are given to simplify. X plus 2y is equal to 4 minus x plus y is equal to 5. We have to use the matrix approach. Now, look at this. You see that the coefficient of the x term here is 1. That's the first element. Coefficient of the y term here is 2. The second element. Coefficient of the x term here is minus 1. The third element. Coefficient of the y here is 1. Because it's in terms of x and y, this is times x and y, and it will be equal to your constant. We have 4 here, and we have 5 here. So this can be expressed in the matrix form as this. I hope it's clear. Now, if you have to find x, x will be the determinant of dx over the determinant of d, and y will be the determinant of dy over the determinant of d, okay? Now, I'm now going to explain. What do we mean by the determinant of d? The determinant of d will be the determinant of the coefficient, the matrix itself. That is 1, 2, minus 1, 1. And these are coefficients of the variable. 1, 2, minus 1, 1. Okay? So you have 1, 2, minus 1, 1. And so determinant of d, okay, will be equal to, how do you find determinant? The first element times the fourth element. That is 1 times 1 minus the second times the third element. That is 2 times minus 1, okay? 1 times 1 is 1 minus 2 times minus 1 is minus 2. And this will give you 3. Because minus 1 times minus 2 is plus 2. So 1 plus 2 will be 3. So the determinant of d is equal to 3, okay? Then we have to find determinant of x. That's the x, okay? Now, how do we find the x? You need to understand this. Now, the x is a particular matrix. How do we find the determinant? It's equal to determinant of, now let me show you something. Now, because we are finding the determinant of dx, how do you find the matrix dx? Look at this very well. We have 1, 2, minus 1, 1. 1 minus 1 are the coefficients of the x term in equation 1 and 2, okay? Now, you substitute that by the constant. So instead of 1 minus 1, you substitute that by 4, 5, okay? So you are going to have 4, 5 here, but the coefficient of the y term will be the same. That is 2, 1, 2, 1. So you keep the 2, 1 here. I hope it's clear. So how do you find the determinant? This will be equal to 1 times 4 will give us 4, minus 5 times 2 give us 10, and 4 minus 10 is minus 6. So we are done with that. How do we find the determinant of dy? This will be equal to the determinant of, now let's look at this. Because we are solving for dy, the x will be there. That is 1 minus 1 will be there, okay? 1 minus 1 will be here. But take note that 2, 1 is the coefficient of the y in both equations, 2, 1. So we are going to substitute that by the constant 4, 5. And that means we are going to have our 4, 5 here. So the determinant will be 5 times 1, that is 5, minus 1 times 4. Minus 1 times 4 will give us minus 4. So this will be equal to 5 plus 4, and that will be 9, okay? So the determinant of dy is 9. Determinant of dx is equal to what? Minus 6. And the determinant of d, the matrix itself, is what? Is 3. So we are going to solve for x and y. And we are saying that x will be equal to the determinant of dx over determinant of d. Determinant of dx, we had what? We had minus 6, okay? So we have minus 6 over the determinant of d. Determinant of d, what did we get? We had 3, okay? So minus 6 over 3 will give us minus 2. So the value of x is minus 2. What about y? Y is determinant of dy. Determinant of dy is 9. So we have 9 divided by the determinant of d. And the determinant of d is what? 3, okay? So 9 divided by 3 will give you 3. So it means that the value of x is equal to minus 2 and the value of y is equal to 3. So that's how we use the matrix approach to to solve simultaneous equations. So you can solve this simultaneous equation with the elimination method or the substitution method or the graphical method to see. You will get the same values. X equals -2 and y is equal to 3. Take note, what is important is your dx, d, and dy. I repeat, the dx, determinant of the dx, this is what is happening. Now, the d itself, the matrix, you see, the coefficient of the x here is 1, coefficient of y here is 2, coefficient of x here is -1, coefficient of y here is 1. That will be the matrix D. That will be the matrix what D, the coefficient of the variables. Now, the dx, take note that the constant replaces the coefficient of the x when you are finding dx. This is important. So instead of 1 minus 1 representing the coefficient of the x in both equations, 4, 5 will now substitute that. That's why we have 4, 5 here. But the y, 2, 1 will be the same. So when we come to the dy, take note that the x, 1 minus 1, will be here. But instead of the coefficient of the y, that is 2, 1, it will be replaced by the constant 4, 5. That's why it has been replaced by the constant 4, 5. So that's how we find the x, dy, and d. And when you just divide dx by determinant of dx by determinant of d, you are getting x. And that is how come we have -2 here. When you divide determinant of dy by determinant of d, you are also getting 9/3. That is 3. And so in general, that is how we use the matrix approach to solve simultaneous equation. If you have any question, leave your question in the comment section. I will look at it and address it in my next tutorial. God bless you. Follow for more.